Good afternoon, everyone, and welcome to this afternoon's webinar. It's just shortly before 2 o'clock. We'll give everybody just a couple of minutes until they come in to join today's webinar. Thank you for joining us today, and we will get started shortly. All right, good afternoon, everyone. It's just about 2 o'clock. We will get started with a little bit of administration first. I know there's a few people who are having some last-minute registration issues in joining us, but we'll start out a little slowly and give them some time to get on here. And we have a lot to cover this afternoon, so we don't wish to hold anybody up much past 3 o'clock, and maybe we get done a few minutes ahead of time. Thank you for joining us today for today's webinar on hot weather concrete placement planning and prevention of problems. Joining us as presenters for today's webinar are several members of the Pennsylvania Aggregate and Concrete Association's concrete technical community. Susan Armstrong, who chairs our concrete technical community with Central Builders. Also from Western Pennsylvania, Mark Moyer with New Enterprise Stone and Lime Company. Back to the other side of the state, Rob Howard, project engineer with Geotechnology Associates, and also Pat Gallagher with Admixtures Incorporated. I'm Jim Casilio, Director of Technical Services with the Pennsylvania and Aggregate Concrete Association. All right, what we're going to talk about today is some stuff for the producer, some stuff for the contractor, and some information for the specifier. We broke this down into the categories you see here, and we're going to be kind of tag teaming each one of these categories and ending up with some question and answers at the end. So Pat Gallagher is standing by to review your questions. So if you have any, feel free to just click on that question poll right there, type them in at any time. And if one you'd rather try and do verbally, just hit your raise your hand icon under your GoToWebinar control panel, and we'll try and see that your hand raised and see if we can unmute you and ask your question then. This webinar is based on what we call one of our concrete difference publications. This one's on hot weather concrete. You can download it from specifyconcrete.org, but we also have it available for you in our handout section. So on your GoToWebinar control panel, you'll see handouts, and it'll say 3 handouts of 5 there. One of them is the PACA antitrust statement, which will conduct all our meetings in accordance with that, including this presentation. But also you can click on that document, your first one under there, and you can download this PDF on hot weather concreting right from there. Also on that second document that's there for us is we have some additional links for some very valuable resources on this issue. And let's talk about those. That is, and the first one is NRMCA's Concrete in Practice. This is the CIP, Concrete in Practice number 12 on hot weather concreting. On that second document, we have there a link where you can get a copy of CIP 12, excuse me, and all the other CIPs. But also, we have links to show you where you can get these documents. Now, What we based everything on here in the presentation, and what really is the guide, is the ACI publications, 305R, Guide to Hot Weather Concreting, and you see the 305 over there, 304, excuse me, specifications for hot weather concreting. These are important documents. My advice to you, whether you're a producer, whether you're a concrete contractor or a specifier, is the first time you're reading these documents is not the time where you're preparing for a dispute and trying to get paid or in a trial because you didn't do something right. Somebody once said, who reads these specifications? Well, only two people, and that is lawyers and expert witnesses. So we've got provided links to these documents. Of course, they're not easy to get to, but if you're doing something that's contrary to the guide, or somebody's asking you to do something that's contrary to the guide, it's good that you know where the answers are and what really information we're basing all this on and state-of-the-art practice is coming from. So right from 305R, what's the definition of hot weather concrete conditions? Well, any condition that's going to impair the quality or change the performance of hardened concrete, including what you see here: high temperature, high concrete temperature, really low humidity, wind speed, or a lot of sun. All those things are going to affect the concrete performance, how it performs, and what we need to do to address it properly. Let's talk a little bit about the effect of high temperature on concrete. One of my favorite slides for trying to relay this information both on hot weather and cold weather. What you see here is the effect of the same mix but being cured at 3 different temperatures for a total of a year. Went out, as you see, 365 days, all from the same concrete. You see they did this at a 0.43 water cement ratio, very typical of what you see at 4,500 or higher performance mix, a bridge deck mix, something like that being done at. So this is relevant, real concrete. But what's important about this slide is to notice the shape of the curve. The shape of the curve changes when we get in that 73-degree range as opposed to 55 and 40 degrees. What's that telling me is that we are changing the mechanics of the chemical reaction that underlies cement hydration. Now, cement hydration is not just one reaction. It's a very complex, multiple reaction, a lot of different stuff going on. And if we want to put a webinar on that, we could put all sorts of chemistry up there, but that would be a webinar that would be akin to being in a dentist chair for 2 hours going through all that chemistry. Hey, we're construction people. We don't like chemistry, but it's important that we know that the effects of temperature, we're going to change the underlying chemistry on that. And we all learned way back when that the ideal temperature for concrete, best strength gain, best everything, is about 55, 60 degrees. And you can see that out there. However, look at how the changes of that curve as we go higher and a little bit as we go lower. Another way of showing the same kind of strength. They say about strength of concrete, you want it early or you want it late. So we can give you some great strengths at an early age by keeping it very warm. But we suffer 28-day and later strength by it. As you can see, the higher the temperature, greater the 1-day strength, but the less the 28-day strength. Now here's a very interesting slide, and let me see if I can do a little bit of notation on the slide here. What you see in the brownish yellow color and in the blue color is the set times of 2 different mixes, both of the same proportions but with a different type of cement. So notice, if we can here, that at 50 degrees here's our set time, and then as we go to 73 degrees we've got much quicker set time, and as we go even to 90 degrees we have even a quicker set time. Same thing with this mix in blue. Much faster setting time, different type of cement, but as the temperature goes up, our set time goes down. In addition to our set time, there's also something else that shortens or changes. Look at the difference between initial set and final set as our temperature increases. And if I can kind of asterisk that there is our time difference between initial set and final set. And any even rudimentary new finisher, they've worked through the seasons, they know that this window, or our finishing window, does changes as the temperature is affected. So you see the finishing window here, and then you see the finishing window is even smaller here, and it's even less here of a finishing window as our temperature increases. So to me, this is showing that this is another effect of the temperature changing the mechanics of our underlying cement chemistry as it goes up. Oops, here I got to get rid of those drawing tools. Forgive me, I've got to erase all my drawings on there. So that's a little bit about the effect of temperatures on concrete. Now, to discuss what you can do with the mix design, we'll turn the presentation over to Mark Moyer with New Enterprise Stone and Line. And as soon as we can do that, Mark, I will make you the panelist and the presenter, and you've got it.
Okay. Okay. Okay, we good, Jim?
Looks good, Mark. Thank you.
Okay. Good afternoon, everybody. What can be done with the mix design? Well, not a lot, but there are some things you can do. I'll briefly go over some of these things that we can do. The first slide I have here, what can be done? There's a little bit of tongue-in-cheek with that, as everybody can read. I'm not going to read it for you. But the biggest thing, and Susan will touch on some of the challenges and the logistics are, you know, summertime is a fickle time. We have rain, as everybody's seen, and we have a lot of heat and everything. And, you know, you're just not always ready. You get a call that you need a bridge deck here in 3 days. We got to ship a bridge deck. As I put on here, not every supplier's got a little ice factory ready. So you have to have extra communication, and you want to make a change. The specifying engineer is going to want to review it. So I just encourage everybody to be proactive, not reactive. I know everybody hears that same thing, and that's a popular thing being said, but I truly really mean that. So moving along to our next slide, if I can get it to move along to the next slide. There we go. What can you do with the meat potatoes of the mix? Well, shrinkage is a problem. Hot weather concrete's the problem. They're related. The natural inclination is for everybody to add water, and that's done. Everybody listening, everybody in this business knows it's the kiss of death. By increasing your coarse aggregate volume, you actually requires less water due to less surface area. It can really improve a mix, actually. Now, finishers are fickle people, and they don't like any more rocks in it than necessary. So some of the other things we can do is use of chemical admixtures, and they're the next best, and sometimes they even work in concert with the volume changes. They can really fill the bill. Just want to point out slump retention admixture. It's a personal favorite. It does not retard the set of concrete. Okay, everybody, please understand this. It does not retard the set at all. A retarder, that'll affect the set of concrete. But retarders only affect 2 phases of the hydration. There's a product called a hydration stabilizer. Everybody hears that, and some people think it's the same as retarder. It is not. Hydration stabilizer actually can put your concrete to sleep for several days if need be. They're a more advanced product used a lot, I guess, in pervious concrete. You don't want, obviously, things to set real fast. Another item you can do with the mix design, obviously, is use of microfibers, and we'll discuss that a little bit in cracking further on. Microfibers or fiber mesh or any of the other common names that are used, they're really designed for plastic shrinkage cracking, and that's another issue we'll discuss further. So those are really the only things that can actually be done on paper. Everything else is more of a physical nature or with the raw material. The raw material, first thing obviously is cement. Type 2 is good. There's a lot of 1-2s that are out there. Type 4 is the best, but you know, you're not going to find that very easily, if at all. Jim, you or Susan can correct me. I don't know of anybody that has type 4 currently right now in the whole East Coast, do they?
Not that I'm aware of.
Okay. So, obviously that's a derivative of the heat of your mix, the cement. Uh, Obviously, getting extra warm cement from the mill causes an issue. If there's any way you can set tankers aside, let them cool down, that helps. The use of SCM, supplementary cementitious materials, fly ash, slag cement, fume, they all help. And obviously cooling the concrete down, everybody's favorite is use of ice. Liquid nitrogen is one thing that can be used, but I would strongly, strongly caution people, if you've never used it, get somebody who has to work with you, because it is very dangerous. You can cause life-threatening injuries with it if it's not handled properly. Okay, production concerns. I believe, Susan, this is where you kick in. Am I correct?
It is.
Okay. Well, here she comes.
All right.
You got it?
Yes. Do you guys see my screen?
Yes, we do.
Yes.
Okay. Awesome. All right. Production facilities and procedures should be capable of providing the required quality and quantity of the concrete under hot weather conditions as production rates required by the project. Batching procedures under hot weather conditions do not differ from good practices under normal weather conditions. The plants and the trucks should be inspected and in good operating conditions. And keep in mind that equipment breakdowns can be much more serious under hot weather conditions. So a few things to consider when placing concrete in the hot weather conditions are: you use materials and mix proportions that have a good record in hot weather. Reduce your concrete temperature, like Mark said, with ice, liquid nitrogen, chilled water. Concrete consistency and transporting, placing, and finishing are critical. We want to minimize the moisture loss of the concrete. We want to make sure that when we schedule the concrete placements, that it's done most efficiently. We want to consider the methods to limit the moisture loss during placing and finishing, such as sunshades, windscreens, fogging, and spraying. Whoops, sorry. To achieve a 1 degree decrease in the concrete temperature, if you cool one or more of these ingredients, you will see a drastic reduction in the concrete temperature. So if you can reduce the cement temperature 8 degrees, you'll get 1 degree concrete temperature. Water temp 4 degrees down, 1 degree. But if you can reduce your aggregate temperature 2 degrees, you can get a 1 degree decrease for every 2 degrees of aggregate temp. So obviously you can see that that is the biggest bang for your buck. Now the methods of cooling include using chilled water, ice, cooling the mixed water with liquid nitrogen, cooling the concrete with liquid nitrogen, or cooling the coarse aggregate with cool water or inundating the aggregate. It doesn't hurt to cool the exterior of your mixing drums either when they're being loaded. In my case, I've got dark blue drums that just soak up the heat of the sun. So typically when we have a mixer under the bin getting loading, we will have continuous water spray on those drums to cool them. Biggest thing is how much ice do I need, or how much do I need to reduce my concrete temperature? Well, here is the wonderful equation that ACO 305 has. It is rather complex. It has been converted into an Excel spreadsheet, but better yet, if you go online and Google estimating concrete temperature, there's quite a few programs out there that will do this for you. Now we want to make sure we use a concrete consistent that allows a rapid placement and consolidation. We want to ensure that the concrete mix is well graded and workable. Summertime is a notorious time when the stone producers want to pull the 1/2 inch material out of the 57s to use it in asphalt. So make sure you keep an eye on your gradations of the coarse aggregate.
Easy there, Susan.
I know, Mark, but hey, we're talking the white stuff today. The use of mid-range or high-range water reducers may be necessary to expedite the placement. Mixer revolutions at mixing speed should be held to a minimum to avoid unnecessary heat gain of the concrete. Make sure that the mixer drums are free of buildup on the fins and do not have excessive wear of the mixing blades. Do not stop the drum for an extended period of time. There's a potential for a false setting problem, or you're going to flatten your mixer rollers. But schedule the concrete placement to avoid the extreme heat. It may be necessary to place the concrete at night or during more favorable weather conditions. Remember that your concrete supplier, though, has limited resources and most cannot produce 24/7. Now, Mark touched a little bit on slump control, but slump control is critical. It's not unusual to hold water while you're batching, but you should take care to avoid withholding too much water from the batch, as this could result in inadequate mixing, dry packing that reduces the effectiveness of the admixtures, or delivery of a slump below the specified minimum. Set retarders can be used to extend the workability of the concrete, but make sure the contractor is aware if a set retarding admixture is being used, because protecting the concrete in the field is even more critical at that point. The set retarding admixtures improve workability, they'll reduce segregation, provide superior finishing characteristics for flat work and cast surfaces, allow for flexibility in the scheduling, placing, and finishing operations, offset the effects of early concrete stiffening during the extended delays between mixing and placing. They'll also help to eliminate cold joints. They'll lower peak temperatures and or rate of temperature rise in mass concrete, thereby reducing thermal cracking. They will also increase compressive and flexural strengths. Now, the up-and-coming admixture of choice is a slump retention admixture. These products provide flexible degrees of slump and workability retention without retardation of the concrete. So they can be used in low to high slump mixes, including self-consolidating, can be used alone or in combination with normal mid-range or high-range admixtures, and can improve early and late age compressive strengths. Now we're out on the job site. If you fail to plan, you're going to plan to fail. Plans for hot weather concreting should be made to minimize the exposure of the concrete to adverse conditions. Whenever possible, slab placement should be scheduled after the roof structure and walls are in place to minimize drying winds. A roof also reduces thermal shock from rapid temperature drops caused by the wide day and night temperatures or cool rain on concrete heated by the sun. Monitor the weather to increase awareness of potential issues at or during the placement. Those scattered afternoon thunderstorms aren't uncommon this time of year and can wreak havoc on an exposed floor slab. Be aware of damaging combinations of high air temperatures, direct sunlight, drying winds, and high concrete temperatures. Concrete placements should be scheduled to avoid the hottest portion of the day. It may be possible to place the concrete at night or during more favorable weather conditions. The hottest part of the day usually occurs between 3 and 4 p.m. Cooling doesn't typically start until after sunset, which in the summertime is around 9 p.m. Preparations should be made to transport, place, and consolidate and finish the concrete as fast as possible. Equipment for placing the concrete should be suitable design and ample capacity to perform this efficiently. All equipment should have adequate power for the work and be in top operating condition. Cool the forms, reinforcing steel, and the subgrade before you start placement. Restrict placement of the concrete to the early morning, as we said earlier, and expedite all elements of the placement, including delivery and placement. Site traffic should be coordinated for quick turnaround of mixer trucks. And if you're pumping, it's extremely advantageous to have space for 2 trucks at the pump hopper. In hot weather, it is necessary to place the concrete in shallower layers to ensure coverage of lower layer while it still responds readily to the vibration. For flat work, the subgrade forms and steel should be moistened, as I said earlier, but keep the operations confined to a very small area and use foggers to cool the air, forms, and steel immediately prior to placement. Can't stress this enough. Curing is critical. In hot weather, curing and protection are critical due to the rapid moisture loss from fresh concrete. The curing actually starts before the concrete is placed by wetting the substrate surfaces with water. Sunscreens, windscreens, fogging, and evaporation retardants can be used in hot water concrete placements. Since concrete strength gain in hot weather is faster, curing period may be reduced. Now, if we look at this chart on the right-hand side, we will see compressive strengths, whether it is cured in the air the entire time or moist cured the entire time. And you can see the dramatic difference in strength between the two. But what do we really mean by curing? Well, curing is maintaining of an adequate moisture content and temperature in the concrete at early ages so that it can develop properties in the mixture that the mixture was designed to achieve. It begins immediately after placement and finishing so that the concrete may develop the desired strength and durability. You cannot get away with minimal or no curing in hot weather. Wet curing, the old way is the best. And as much as we would love to see water cured for 28 days, it's not always practical. Try to push for water cure as long as feasible. It will produce the strongest and most durable concrete. There are 3 functions of curing. We maintain the mixing water in the concrete during the early hardening process. We're going to reduce the loss of mixing water from the surface of the concrete, and we're going to accelerate strength gain using heat and additional moisture. At this point, oh, no, it's still me, isn't it? Membrane curing.
Yeah, you have 2 more, I think.
Yes, I do. It is the most practical of all curing methods. Next best thing, water. Membrane-forming curing compounds are usually used to retard or reduce evaporation of moisture from the concrete. They can be clear, translucent, and white pigmented. In hot weather, it is recommended to use the white pigmented compound to reflect the sun. Be sure you coat all exposed areas. Do not forget the edges. And here is a good example of somebody spraying on the pigmented white curing compound. Forms should be covered and kept continuously moist during the early curing period. Formwork should be loosened or removed at the earliest practical age without damaging the concrete. And provisions should be made for an approved curing method to begin. So just when you strip the forms, it doesn't mean you're done. This is when it is more critical. You have to make sure you come back and cure the structure. Now I think it's Mark's turn.
Yes, it is. Thank you, Susan, for running us through what we can need to do with the plant and things we have to worry about the job site. Now to discuss some problems that have occurred and what we can do about them and maybe learn from those lessons. Mark's going to join us again and run us through some problems that he's seen and what we can do against those. So, Mark, you're all set.
Okay, everybody sees my screen okay. It's starting out with effects.
Yep, you're good.
Okay, good. Well, the first one obviously is one that everybody sees. It's cracking, whether it's a dry cracking or a plastic shrinkage cracking. Now, plastic shrinkage cracks are entirely different than dry shrinkage cracks. I'm going to go over the dry shrinkage cracks first, then work myself into the plastic. But the plastic, just so everybody knows, the biggest difference is they occur while as it says, the mix is still plastic. It's not completely set yet. And typically the cracks for plastic don't go much more than 1/4 to 3/8 of an inch deep. But dry shrinkage cracks, are caused just by the bullet points on there, the rapid loss of moisture, shrinkage. The aggregate content plays a big part of this. I'm sure many of the producers that will listen to this webinar down the road or later understand very well that the biggest goal is to keep the floors from curling and from cracking, and mixed design portion that I briefly touched on has a lot to do with that, and that's the aggregate content. Other factors, obviously, the paste content, water cement ratio, relative humidity, as Susan mentioned, And just real quick, wanted to throw an item before I forgot about it. Retarders was brought up several times. Just as a safety thing and as a disclaimer to the presenters on this and PACA, as a producer, make sure that your customer in the field knows you are using a retarder, because if somebody's pouring a wall, every set of forms has a different pour rate, and it's a pour rate of feet per hour. So you don't want to be putting retarder in thinking you're doing a good job for somebody and they're pouring a pier stem and they shouldn't be going more than 4 feet an hour and they're pouring 6 feet an hour. Next thing you know, the form blows and somebody gets hurt or badly injured. So I had to back up real quick, Jim, and throw that in there. Picture of dry shrinkage cracks. We're back to the cracking. You know, everybody's going to a finisher or to a home or to a project and said, yeah, I cut the saw. I saw cut it the next day. Well, you know, it probably needs cut the same day, especially with hot weather. You could probably get away with the next day on a cold weather application, or if you had a mix that was really, really slow setting. But if you wait till the next day, Mother Nature's already put it in there for you, and it's a fully functioning joint. It doesn't look pretty, and people get really upset, but this is what happens. Plastic shrinkage cracking, as I touched on briefly, it typically happens early on in the setting process, but I want to mention that it does occasionally happen in the cold weather, cool and cold weather also. A lot of things that are put together that cause that, as we mentioned, rapid moisture loss, which you can have in the cool and cold weather as well. But the conditions are really what dictates it. I have a plug in there for Concrete in Practice number 5 for NRMCA. And please, when you see the plastic shrinkage cracking, the picture I'm going to show you next, don't confuse this with delamination. Delamination is a completely different thing. And there's a picture that I'm sure everybody's seen time and time again. It's plastic shrinkage cracking. And it's nothing can be done about it. There's finishers that will try to get back on the slab and try to get it sealed up or healed up, and then that's where you get into the delamination occurring, because they're putting water on the surface, or they'll try to scrub some grout into it, and basically when the bleed water works its way through, the damage is already done. This is a really nice graph used to determine probability of plastic shrinkage cracking. Everybody remembers, I'll just use my mouse. I'm not going to draw like Jim did, but you can just follow. If you have the humidity to the concrete temperature down to the wind velocity, and it's greater than 0.2, you're going to have problems. And you're probably, if you don't have a evaporation retarder that Susan mentioned, like a Confilm or Evapora, you're going to have an issue. You're going to have a plastic shrinkage cracking. So how do I know if I'm apt to this? Well, there's several apps. Several PACA member companies have apps that you can go online and get and plug in your location based on your zip code, and it'll tell you the weather conditions. It tell you if maybe you're in a bad situation. This is a Kestrel meter. Anybody who's done PennDOT work and bridge decks have seen this. You basically hold the back of the unit into the wind. If you hold it off axis by like 5 degrees, it'll reduce the accuracy by 1%. But for the most part, you hold it into the wind, and you can take a reading, and it'll tell you basically approximate your evaporation, what you're going to be losing. And I would specifically tell somebody, if you have a large commercial placement, a guy can put this in his back pocket, no different than a cell phone, break it out every 15 to 30 minutes and check, because weather conditions change. Effects on strength. Okay, we're going to get away from cracking. We're going to what can happen to the strength. We've touched on that. I have a feeling I have to put this in here because of curing, and I don't want to take too much of Rob's presentation next, but as a reminder, what ASTM tells you for a curing temperature for specified strength under 6,000 and above 6,000. If you don't adhere to it, you're going to have issues. And another nice chart like Jim and Susan both showed, We can't show this chart to you people enough, and please feel free to share it with your contractors, whoever can learn something from this. But this is real stuff. Well, we mentioned water. I mentioned about putting too much water in. Look at the strength loss just based on adding water from a 3-inch slump that was designed at 4,000. Now you're up to a 7 with water. Look how much you lose there, 1,300 psi. You can never get that back. Not to mention the curling you can incur and the cracks that you'll incur. Durability issues. Another issue with hot weather concreting. Overworking the surface. Everybody worries about getting a beautiful surface. You got to get it sealed up faster. You've got to get more people there. Get more people there. Consider the amount of time needed to do it. Or consider a smaller placement. You don't want to end up with cold joints. You don't want the work to suffer. Those are just some of the many things. This is a video. I don't know how well it's going to play. One of our attendees took this video several years ago, and I'm going to play it for you. Hopefully it's not too choppy. This is guys pouring in warm weather, and that, I believe, if memory serves me, it was 50, 60 yards of concrete, 2 guys by themselves. I'm going to let this play for a few more seconds here, let you guys see this. This is just guys that need to pour it wet because they didn't have enough help, and they backed themselves into a corner. They had no issue with us filming this. I mean, you can see how wet it is. And just for the record of the video and the recording we're listening to, that is not Super P in that mix. That is all water slump. And as you can see, as the coarse aggregate hit it right here, it disappears. It's sinking to the bottom. And this will most certainly fail. So I'm going to stop that and move us on to the next one. Oops, there we go. Other surface issues. Again, user evaporated retarder. Can't stress that enough. Enough people don't use it. And I know it's not supposed to be used as a finishing aid, but let's be honest, it's better than putting water on the surface. And a good curing compound after the final finish. If Susan mentioned, good old-fashioned water is the best thing. If it's not feasible or conducive, use a good quality curing compound, then seal it. The guy putting some con film on. Placement, minimizing crack potential. Some of the things that Susan mentioned as well, making sure the subgrade is good and wet, wind breaks, sunshades, all the things that you can possibly do. Fog the slab. PennDOT generally requires you to, at least in some of the districts, to have a fogging machine right on the bid well to keep the percent of humidity high enough so you don't have any issues with your Kestrel meter. And of course, plastic fibers, the microfibers, they can certainly help, at least with the plastic shrinkage cracking. And obviously the last thing is reducing the amount of time, placing it to curing it. Got to do it quick. And I believe I'm going to switch over to Rob, I think. Yep. Rob, here it comes to you, my friend.
All right, Mark, thank you for going through problems on the job site. One of the bigger areas that is always often of concern is we talked about what to do with the concrete, but test cylinders on the job site can be very problematic and during hot weather. And here to talk about that in more detail and to find out a little bit about what they do on their job sites to get quality testing done is Rob Howard with Geotechnology Associates. Rob, you're up.
Good afternoon. Can you see my screen?
Yes.
Okay. I want to talk a little about the concrete cylinders that we make, and most of the things that we're talking about is the same for flexural strength beams that we make. There are 2 different purposes for field concrete cylinder testing. One test is determining the strength potential of the concrete as delivered to the job, and the other is determining the strength of the concrete in place at a given time. One very important difference between the 2 test procedures, the method of curing required for the cylinders. Because correct cylinder curing is commonly neglected, invalid test results are often misinterpreted as test failures. So the first type is standard cure cylinders. The purpose of the cylinder test is to confirm that the strength of the concrete as delivered to the job meets the specified design strength and is typically at 28 days. So during the first 24 hours, all cylinders will be stored in a surrounding temperature of 60 to 80 degrees Fahrenheit for less than 6,000 psi concrete and 68 to 78 degrees Fahrenheit for strengths greater or equal to 6,000 psi. Within 16 to 24 hours, all cylinders were removed from the molds and stored in a moist condition until time of test at a temperature of 73.5 plus or minus 3.5 degrees Fahrenheit, and we do that in our controlled temperature laboratory and our controlled temperature tanks in our office. Field cure cylinders. The second purpose of cylinder testing is confirm that the time of which concrete in place is strong enough for forms to be removed or for the structure to be put into service. Cylinders are stored as near as possible to the concrete in place. Cylinder molds are removed at the time the forms are removed. Cylinders are cured to duplicate the curing of the concrete in place until the time of test. And I just want to emphasize that field curing cylinders is not used for a basis of strength acceptance for the concrete. It's only for the items that I referenced here. So I looked at the NRMCA publication number 71, and they talked about the effect of hot weather on concrete cylinders, why concrete cylinders test low in hot weather. There are several causes, and testing procedure may be the number one. Two of the three primary variables investigated were the effect of concrete temperature and the effect of delivery time on 28-day cylinder strength. The higher concrete temperatures caused only a minor reduction in the 28-day strength in the study. The reduction in strength when the time was delivery was extended from 20 to 90 minutes was 2 to 3 times greater. So that was a much greater effect than the higher concrete temperature itself. Loss in strength or extended mixing time was no greater at 95 degrees than at 65 degrees. But the third variable, the temperature at which the cylinders were cured on the job, had the far greatest effect on the cylinder strengths. Cylinders molded, let me make this full screen. Cylinders molded from various mixes were exposed to two different curing conditions for the first day. One set was cured for the first 16 to 20 hours at 70 degrees, and the other set was cured at 100 degrees Fahrenheit. After the first day, both sets were cured in the standard moist room condition. The loss of strength by early exposure of cylinders to 100 degrees Fahrenheit averaged 10% of the 28-day strength for all mixes. This was double the loss that occurred with longer delivery time and almost 6 times the loss of strength that occurred with higher concrete temperature. The strength loss caused by non-standard curing of cylinders was consistent for every one of the various mixes tested. The approximate 10% loss in cylinder strength attributable to the difference in first-day curing was common to all the mixes tested. So based on the test result, it was not difficult to speculate about what happens on many projects where cylinders stand unprotected from the sun. Alveon temperatures need not to be extremely high for temperatures to reach 100 degrees Fahrenheit in direct sunlight. If exposure for one day can reduce 28-day strength by 10%, what happens to cylinders molded from a Friday pour or the day before a holiday? In both those instances, we do recommend that we pick them up the next day if our people that we're working for will allow us to. We always known and accepted the generalization that hot weather reduces concrete. We saw that earlier in this presentation. This report provides evidence that the major part of the loss is often not in the potential strength of the concrete mix as delivered to the job, which the cylinder test is supposed to be measuring. It is the loss in cylinder strength caused by non-standard curing of cylinders while on the job. So a summary of the test results are shown in this table, And it shows what happens when you increase the concrete temperature to 65 to 95 degrees. You extend the delivery time from 20 to 90 minutes, and you cure cylinders at 100 degrees Fahrenheit for the first day. And on this study, it showed that curing cylinders improperly was giving us the greatest strength loss at 28 days. I think I went the wrong way. So, looked into ACI 305R, and it reiterated that if the initial curing at 100 degrees, the 28-day compressor strength of the test specimens will and may be up to 10 to 15% lower than cured at the required temperature. If cylinders are allowed to dry at early ages, strengths will be reduced even further. So proper curing of the test specimens during hot weather is critical, and steps should be taken to ensure that the specified procedures are followed. So what do we consider when we consider all these variables? Well, carefully read and understand project specifications. Pre-construction meeting can address hot weather concrete practice. And, you know, Susan and Mark talked about temperature control at the plant on site, whether they have an ice factory, whether they have chilled water. You can discuss all this at the pre-construction meeting. You can talk about the contractor's responsibilities and expectations. You can talk about the supplier's responsibility and expectations, and you can talk about the testing lab's responsibilities and expectations, and you can prepare yourself, as Susan said, for the ambient conditions in which you are going to be performing. So what else can you do? You can frequently document the air, concrete, and subgrade, subbase temperatures, the humidity, wind, and evaporation rate. So if you have a job site and your testing frequency is every 50 cubic yards, maybe you increase your temperature testing to every other truck. Maybe you do sloughs every other truck. Maybe you provide more information so that you can provide a better product. You document placing and curing procedures. All these notes should be part of your permanent records, and make sure that you collect and review the material delivery tickets. Other considerations, of course, you want to sample and test in accordance with applicable ASTM standards. As stated before, you can increase your testing frequency. You want to avoid moisture loss in your composite sample, the sample that you get from your truck or your pump. You want to avoid moisture loss in the string specimens. You want to cover them with their plastic lids. And you want to maintain proper curing temperatures for your strength specimens, and you can use min-max thermometers to help do that. As you see, there is a cooler filled with water with test specimens in it, and that's, in our mind, it's a very easy way to cure the cylinders because it's easy for us to move a cooler around. We can control temperature a lot in that cooler by, you know, in the wintertime, that lid might be fully closed or slightly ajar. In the summertime, we may leave that lid open and just cover that with wet burlap. But we're going to try to do whatever we can to maintain that temperature in that 60 to 80 degree range for under 6,000 PSI concrete. You want to keep it cool. You know that you have all these big shade trees in the middle of your job site, so make sure you use those. Cover your plastic molds with watertight lids, or use plastic, use with wet burlap. Total immersion in water is the best curing method for cylinders cast in plastic molds. One study has shown that it's the only method that prevents all moisture loss during initial curing. You can use water-filled insulated coolers or tanks, sawed-off 50-gallon drums, insulated temperature-controlled chests, which is one of those you see there to the left. Be creative. Ask your contractor for help. Don't assume that because you're out there by yourself, you're taking your cylinders, it's your responsibility. It is. But you can ask someone else that has their neck into the game, someone else that is going to make sure that the strength comes up. Maybe you can get assistance on the job site for materials that you can use to help keep your cylinders cool. Use shaded areas, canopies or tents. Wet burlap cover a canopy or tent will work also. Summary: never place cylinders where direct sunlight can hit them. In hot weather, radiant heat combined with the heat of hydration will most likely drive the cylinder temperature above 80 degrees, which can reduce to 28-day strength. And one of the things that we emphasize in this presentation is they're using the cylinders that we standard cure in our lab as a representation of the concrete placed in the field. And if we are not curing those cylinders correctly, then there's no way that they can represent the concrete placed in the field. Care in handling, shipping, and storage of cylinders is very important for accurate test results. Any storage method that increases the chance of a low test result is not a good method. Any questions?
All right, Rob, thank you very much. Pat, are you able to join us on audio and go over some questions?
Can you hear me, Jim?
Yes, we can.
Okay, yes, I am. Hey, Jim, there's one thing I wanted to just make mention of is crusting occurring during hot weather concreting. A lot of people will use retarders, and you have to realize that you have to maintain the moisture in the top of the slab there so you don't get crusting while using a retarder.
And that kind of relates to one of the questions that I did see come in, and that is on the surface evaporation retarder that will help do that. Now, Mark, you mentioned that. Can you elaborate a little more on that product as to when you can use it and how you use it?
Well, Jim, it's supposed to be used prior to the final finish. It's supposed to be used as often as, and each manufacturer has their own spin on it. But as Pat alluded to, you do get crusting with retarder, and if you don't use it, you will almost guaranteed have plastic shrinkage cracks. So everybody be forewarned. There's a lot of inherent risk using retarder. There's a lot of good about it, but there's a lot of inherent risk. And like I said, it all kind of meshes together. Hot weather, cracking, all these kind of bad things happen, all these extremes. But it needs to go down. I know it's not supposed to be used as a finishing aid, but if you're going to put it down versus water to get something somewhat closed up, use it there, use it after the final finish, as soon as you're done. And you can, I don't think you can use it as a intermediate curing, but you could certainly put it down prior to putting the curing compound down. It'll hold, I guess, based on certain manufacturers, sunlight and wind speed and everything, some hold longer than others. So I think a good rule of thumb is, obviously, as Susan and Rob and I have all mentioned, hot weather, get it down, get it struck off, get it finished, get it cured immediately. Sorry, I went a long way around to get to there, but yeah.
Okay. All right. Pat, some additional questions?
I don't see any, Jim.
Okay.
I have a quick question.
Go ahead, Rob.
I don't know if my screen is still up, but Susan touched on to achieve a 1 degree decrease in concrete temperature, cool one and more of its ingredients. If we reduce the cement temperature by 8 degrees and the water temperature by 4 degrees and the aggregate temperature by 2 degrees, would we get a 3 degree decrease in the concrete temperature or more?
Susan?
I'm going to say yes.
Yeah, you can actually maybe even get a touch more if you can put them all in concert, I think.
Yeah, I always like to be
that's what I'm
conservative,
assuming.
but
Yes,
I will
Rob.
tell everybody listening, if you have a second water chiller, if you can run chilled water on your coarse aggregate, you can see a 10 to 15 degree reduction in your coarse aggregate temperature real quick. Huge, huge difference.
Hey, Mark, I want to add also out on the job, just to make sure the sub base is moistened and the evaporation cooling will help with your concrete set times.
Yes, I believe we had a slide mentioning that somewhere in there, Pat, about spraying
Yeah, I
sub
saw
base.
it. I just wanted to bring it up again because it's critical.
Another question that came in, Rob, you mentioned min-max thermometers. Is it required to document maximum and minimum curing temperatures when you're making test cylinders for acceptance?
We do not. We have it on our field form, but we don't have that on the form that we provide with our breaks.
Okay.
So I don't know if it's required, but I know it is recommended. And cold weather.
I believe it
wintertime
isn't it, Rob, in ASTM C31? I thought it was required.
I'm not sure off the top of my head. I know that we do it in the field, but we don't provide that information with our break report.
Okay. But your advice is that it's something that is, when doing a quality job on testing, that's what should be done.
Well, how else are you going to know whether you're within 60 to 80 degrees?
That's the question. Another question that came in for anybody that wants to take it, is there a maximum temperature on concrete?
I think that depends on each type of mix. Double A, PennDOT double A accelerated, they allow up to 100, and that makes a lot of sense. You want it to set fast. You want to get strength 4 to 7 hours so that you can get MPT off the roadway, because then every minute the MPT is on the roadway, that's another chance of a traveling motorist to have an accident. And conversely, mass concrete, you probably don't want anything higher than 65. As you alluded in the beginning, Jim, the ideal concrete is 55 to 65.
Okay.
Yep.
Susan, I believe you guys are supplying a project right now with mass concrete, and you have a maximum temperature requirement of what?
75.
75. So as to answer that person's question is, no, there's not one maximum number that you can use. You've just heard where one place has got to be over 100 and one place has a maximum of 75. So it is project and application specific.
Jim, I wouldn't mind to add one thing at this point. We were talking so much about curing of cylinders on the job site. We have had great success with casting the cylinders and immediately submersing them in a lime bath. The benefits are amazing. You can control the temperature so much easier. You can see if there's vibration. And I mean, you know that you have constant moisture control.
Robin,
So
I believe you have a slide of that, if you can bring that up while Susan discusses it.
I mean, we were working on a project, 2 different contractors. One was having cylinder issues, the other one was not. I mean, same mix, delivering the same day. Difference is one was curing the first 24 hours in water. The second just had them sitting there in the black molds with, caps on. Of course, right,
And
2 feet of a pile driving machine.
And if you remember, we had one of our technical committee meetings, someone was talking about how if you don't get your cylinders immediately in the water after molding, if you're waiting 15, 20, or half an hour, the difference of that spike in the heat in the cylinders, how it adversely affects the 28-day strength if it peaks real high in those first, as soon as you get them molded, and do not put it in the water.
All right, that is, as Rob goes to bring that slide back up, that would be a good spot to end on that, seeing no more questions for today. I want to thank everybody for joining us on today's webinar. Excuse me, we'll have more coming up, talk about timely topics and new innovations and problems that we face in the concrete construction industry. So you were receiving email notifications from Ken Crank through specifyconcrete.org or myself. So we thank everybody for joining us today. Quickly, also for all PACA members on the line, this webinar is available as a recording. If you'd like it to share it with your customers or other people within your organization, please contact me and we will gladly make that available to you. Thank you, everybody. Go out and enjoy the nice, warm, I ain't going to say hot, day today in Pennsylvania, and talk to everybody soon. Thank you.
Thank you. Yeah, bye.
Thanks, Jim.